Okay, so this is some extra weak acid and base problems. Example problem number 100. A weak base, methylamine, that's what this is called, is dissolved in water. Complete the table below and solve the equations needed to determine the pH of a 0.15 molar solution. So I rewrote the equation right here, and then I created an ice table right here. And initially I have 0.15 molar, none of this and none of this. And then I will lose X, and I will gain X and gain X right here. And if I wanted to find the pH, this would be the thing that would help me get into the pH square. So I'm going to look for that. And then I would end up with 0.15 minus X, X, and X right here. And then I could take products divided by reactants, products, X squared divided by reactants, ignore this X and say it's small compared to 0.15, and I'd be able to set that equal to the KB, because this is a base, and it gives me the KB right there. And then I'd multiply both sides by 0.15 and take the square root of that, and so my OH minus ion concentration ends up being 6.12 times 10 to the negative 4th. And then I can get into the pH square right here, and I move from OH to POH to pH. And I think I did that right here. Here's my negative log of this number, and then the pH would be 10.78. Okay, and then example 101 says HF, a weak acid, is dissolved in water. Calculate the pH of a 0.25 molar solution of HF. You'll need appendix D because we need the Ka. And you can be assured that if this is on an exam, they would give you the Ka. So first of all, write the equation of the weak acid reacting with water. When in doubt, react it with water. And of course, an acid gives away a proton, so we're going to end up with some H3O plus right here. And then we'll ice table that. Initially, I have 0.25 molar, tells me that right here. None, none, and none. When my change occurs, I will have lose X, gain X, gain X. And then at equilibrium, I will have 0.25 minus X, X, and X right here. And then I will do products divided by reactant. And so the products are X squared divided by 0.25. Ignore this X and say it's small. And I would equal that to the Ka, which I looked up in appendix D already at 6.8 times 10 to the negative 4th. Multiply both sides by 0.25 and square root it. And I end up with X equaling 0.013. So that is my H3O plus ion concentration. And if it's asking me to find the pH, I move from here to here by taking the negative log of it, and the pH ends up being 1.88.